So we have looked at a basic ratio, how to set up the basic ratio, how to work with a rate and find the unit rate. We've set up proportions, we've solved proportions, we've determined whether proportions are equal. So now, of course, we're going to solve application problems, word problems, with proportions. Now, proportions you will actually use much more frequently than anything else. Case in point, if you work a job, chances are you've asked yourself from time to time, how many hours do I have to work so I can have enough money to do X, Y, Z, 1, 2, 3. It's something that's pretty standard. It's also pretty standard when you are thinking of, can I buy this new car? Can I get this new house? Can I get this apartment? Figuring out how to make all of your money work. Case in point, don't get something that you know you can't afford. Because not being able to afford something is a lot worse than just getting something that might not be the hippest thing in the world, but it works. I know I have a 2005 Toyota Camry. I've gotten plenty of offers to get rid of it and get another car, but I don't want to pay a note until I absolutely have to, because that's money I can keep in my pocket and do other stuff with. So remember, a proportion is two fractions set equal to each other, and we can use proportions to solve a whole bunch of problems. We can use it to solve a whole bunch of problems. So of course, the steps for solving any kind of problem are still the same. Read the problem, work on a plan that involves you reading it again. Set up the problem, solve the problem, give the answer, check your work. So we're just now doing it in the case of a word problem. So that's what a lot of today is going to be. We're going to be looking at word problems, we're looking at how to solve them. The setup for the problem, when it's given in this format, is basically the same. It's just knowing how to go about setting it up. So I'm going to model for you the first problem. Now, this problem looks familiar. This was the last extra credit question on the test that you took at the end of the first quarter. So this is the last extra credit problem. Most people did the first three and skipped this one. Not that it's really all that hard, and after you see how it's solved, you'll probably kick yourself for not doing it. So, 60 newspapers cost $27. Find the cost of 16 newspapers. So, we are solving a proportion. We are solving a proportion. So we've read it. Now we're going to set it up. So 60 newspapers cost $27. Now proportion is always set up the same way. One fraction equal to another fraction. The first fraction, you have the choice in how you set it up. First fraction is always your choice. The second fraction is based off of the first fraction. So when it says 60 newspapers cost $27, there are two ways that you can set this up. 60 newspapers over $27, or $27 over 60 newspapers. So, you get a choice. You can set it up however you want. First fraction, you can set up how you want. The second fraction is now based off of the first. Time and cost of 16 newspapers. So when you set up the second fraction, you now have to be consistent. If you put newspapers at the top, the newspapers forever has to stay at the top. So that means your second fraction. So 60 newspapers cost $27. Find the cost of 16 newspapers. So in this case, you have to figure out how much 16 newspapers cost. 16 goes at the top, X goes at the bottom, because you don't know how much it costs. So that's one way to set up your problem. Other way you could have set it up, if you put the money at the top, then that means the X would be at the top. So the key here is you must be consistent. You must be consistent. How you set up the first fraction, that's your business. But that means the second fraction has to be set up the same way. Any questions so far? And one of your questions on your quiz this weekend will be, here's a word problem, set it up. It's not going to tell you to solve it. It's just going to tell you to set it up. But once you set it up, you solve it the way that we did with our problem last week. 16 and 27, 16 and x. So we cross multiply. So I'm just going to write the numbers and not leave the words out. 60 gets multiplied times x. 27 gets multiplied times 16. Now we'll let the calculator do its work. 60x equals 27 times 16 is 432. And you divide by 6. So you get 7.2. Remember, money always has to have two numbers behind a decimal. You put the 0 behind it. So it's going to cost you $7.20. You would get the exact same answer if you did it this way. 27 times 16 equals 60 times x. It's the exact same thing. Questions, example 1. Not seeing or hearing, well, not hearing any, let me check for it. Not seeing any either. Let's go to example 2. Example 2 again. practice this one together, and I'll have you practice setting one up yourself. On an assembly line, James can process 30 circuit boards in 108 minutes. At that rate, how many circuit boards can he process in 252 minutes? So again, when you set up the problem, the first fraction, so you can set up however you want. 30 circuit boards in 108 minutes. So you can do it as 30 over 108, or you can do it as 108 over 30. That's your choice. Your choice, your business. CB means circuit boards, by the way. At that rate, how many circuit boards can he process in 252 minutes? So you know what's now missing. Circuit boards is missing. So that's what gets the X. So it's either X over 252 or it's 252 over X. It depends on how you set up the problem. Side note, I'm just showing it both ways so that you know you can do it both ways. I don't expect you to show it both ways. You just have to show it one way and that's it. Any questions before we solve it out? Let's go. Let's solve it out. Let y'all do some computation with your calculators. 30 gets multiplied times 252. Somebody start calculating that out. And then 108 gets multiplied times X. Say that again. 7,560. So now what do we do to both sides? Divide by 108. So, how many can I make? 70 circuit boards. If you set it up the other way, 108 would have gotten multiplied times X, 30 would have gotten multiplied times 252, and you'd have the same thing as what we just did. It's the exact same thing. Questions, example 2. Proportions, for the most part, is one of the easiest problems to set up. All right, let's give you a chance to set up the problem. All right, so let me, that's for my Algebra 1 kids. They wanted to try to cheat me first. A local paper reported that 4 out of 5 voters surveyed stated that they supported the school levy. So 4 out of 5, so 4 yeses out of total. Okay? I'm fine with that. At that rate, how many of the 42,000 voters in town would you expect to support the school levy? So I 100% agree with that setup. 100% agree with the setup. So now all that's left for us to do is solve it. So now what do we do? or let's multiply it times 42,000. X times 5. Alright, finish me off.
It'll be 168,000. Back down by 5. It'll be 33,600.
33,600. Yes, please. That was bad. Questions before we do another one? Alright. Let's do another one. Recipe calls for 3 cups of flour for 5 dozen cookies. So, cups on the top, the cookies at the bottom. How much flour is needed for 8 dozen cookies? So you know that we need 8 dozen. You don't know how many cups you need. Okay, I can live with that. If you did 5 over 3, then you had to have the other fraction be at 8 over x. So, same rules apply. 3 and 8, going with x and 5. Hopefully you didn't get all the way scared off by seeing decimals. So 3 times 8 is 24. 5 times x is 5x. I divide by 5. How many cups will I need?
4.8.
So 4.8 cups. I want to make all these cookies. Know what I'm making all these cookies for? After the lunch meeting. Questions before we do one more example? Alright, so one more example. A certain medication's dosage is 125 milligrams for every 50 pounds of body weight. How many milligrams of medication is needed for a person who weighs 180 pounds? Those of you who are doing anything medical related, they give you ratios like this, you gotta follow them. Mess up a patient, it's called medical malpractice. For 25 milligrams for every 50 pounds, how many milligrams of medication is needed for someone who weighs 180 pounds? So, who can give me a setup? How should I set this problem up? Good. Good, Steve. 125 milligrams over 50, X over 180 pounds. Now, will the X always be at the top of the fraction? No. It depends on what's missing. In this case, it just so happens that the top part has been popping off as being missing. That is what it is. But the setup is valid. So all we have to do now is solve it. 125 goes with 180. And X goes with 50. Alright, let's do some math. What is it?
It'll be 22,500 equals 50x. 5 is 50. It'll be 420 milligrams.
So 420 milligrams is what this patient who is 180 pounds would take. So that means someone like me, I'd take 420 milligrams of whatever medicine this is. Right. Question before we close up shop. Do the last two examples that I have on Thursday. I didn't see.